All right, so let's take a look at your graphic organizer. So on the left side, at the very bottom where it says natural numbers, let's fill in our definition of a natural number. So right there, next to natural numbers, there in that oval. Sally, what is a natural number? They are counting numbers. Excellent, very good. So when you learned to count when you were a little kid, you started counting 1, 2, 3, 4, 5. Natural numbers, that's exactly what they are. They are those counting numbers. So right next to natural number, right, they are counting numbers. Couple examples of a counting number: 1, 2, 3, 100, 700, 400. Any of those work. So right there for natural numbers. Let's move up in our graphic organizer. A whole number. What is a whole number? David? Good. So whole numbers are all of our natural numbers, all of our counting numbers, plus 0. Very good. So they are all of your counting numbers plus 0. So right there next to whole number. So right there with whole numbers, put 0. Make sure you have 0 in that category. And then you can put 1, 2, 3. You could put 10, 20, 30. You can put your favorite number. So it has to be a whole number. So a number you count with. 77, 88, and so on. All right, let's move up on the chart. So integers. So where we see an integer right there. So on your chart, where you see integers. So take a look at that. Integers. What are integers? Mary? Very good. They're positive and negative whole numbers. So if you look at that number line right there, so on my number line, positive and negative whole numbers, numbers that are found on the number line. There's no fractions or decimals. They have to be whole numbers. So for example, 0, 1, 2, 3 are all integers. And -1, -2, -3, -4. All of those are integers. So this is the first category that we've brought negative numbers in. So far, natural numbers and whole numbers have all been positive. So integers, positive and negative numbers. So add that. Remember, no fractions or decimals. We are only dealing with those numbers that we count with, and now negatives. So whole numbers and their negatives. And the last category on the left side, rational numbers. What is a rational number? What is a rational number? So when you think about rational numbers, they are fractions. Very good. So right next to rational, so right on your chart right there where you see rational numbers, fractions. They are terminating and repeating decimals. If you get terminated from a job, you get fired. A terminating decimal ends. So decimals that end. So, right, decimals, you can write terminate and then in parentheses also write end. And a repeating decimal. So for example, like 0.333333, that 3 repeats. Johnny, give me an example of a decimal that ends, or a terminating decimal. 0.7. Excellent. 0.7. That's a great example. So let's add with your rational number category. Add, for example, let's add 2/3. 2/3 is a rational number. That is a fraction. Add a decimal. Add another one, like 0.4. Add another decimal, like 0.121212. So repeating decimals, decimals that end, fractions are all rational numbers. Are integers whole numbers and natural numbers? Are those all rational numbers? Jesse? Yes, they are. They are all rational numbers. Very good. So any questions on the left side of our graphic organizer so far? So all of these. So this is all of our rational numbers. All of our rational numbers. And let's look to the right side of it. Our other category. So if it's not a rational number, it must be an irrational number. What is an irrational number? If rational numbers end, irrational numbers do not end. So irrational numbers never end. They go on and on forever and ever. And they do not repeat. Rational numbers are repeating decimals. Irrational are non-repeating decimals. They do not repeat. What is that day that we celebrate in March? All your math teachers, you make posters, maybe they brought in cupcakes, or you just talked about it a little bit. What's that day in March? Sam? Pi Day. You are exactly correct. What type of number is pi? That is an irrational number. To me, probably the most common irrational number. You are always going to see that on a worksheet or an assignment or something when you have to classify that. That is an irrational number. We made posters last year and we put them up all around our school. I know we had probably 500 plus posters of digits just going on and on forever because pi, that never ends. You can also add, for example, like the square root of 2. That is an irrational number. The square root of 3 is another example. And then add a decimal, for example, like 3.121222, and then just put dots at the end. So if you see in my example, you see those dots at the end right there. So that means that decimal is continuing and it's going on forever and ever. So irrational are those non-nice numbers. They go on and on. They never end. They continue. They never repeat. So any questions over rational so far? Rational numbers, irrational numbers. We have some great examples. So any questions so far? Any questions? All right, so let's take a look at a few example problems together. So with this graphic organizer, let's take a look and let's classify some numbers.